Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam FM. You are given that the annual effective interest rate is 7.5%. Find the present value of a perpetuity due that pays $500 every 6 months and increases by $10 every year with first payment at time 0. So this effectively means that there's a payment at time 0 of 500, then 500 after 6 months, and then at time 1, the beginning of the second year, the payment is 510, and then there's another 510 payment at time 1.5 years. And then beginning of next year, 520, and then again 520, and then 530, and again 530, and so on. Okay, so here's a solution. What we have here is a level perpetuity and an increasing perpetuity, of course, arithmetically increasing perpetuity. And we can split it two ways. We can say, well, it starts at time 0 with a payment of 490, then 490, and then so on, and then have the 10 immediately there baked in the first year, and then 20 next year, and so on. That's actually a nice approach that I didn't use. I say, well, let's just take a 500 at time 0 and another one at time 0.5 years, so 6 months, and so on. Then we'll work with the 10, 20, and so on separately. So a payment of 500 at time 0 and the payment at time 0.5 have together the present value at time 0 of 500 plus present value of 500 paid in half a year, so 982.24. So there's two payments of 500 in the first year. We can basically say they're equivalent to a payment of 982.24 made at time 0 at the beginning of the year. And similarly, a payment of 10 at time 0 and a payment of 10 at time 0.5 have together the present value at time 0 of 50 times less, because 500 divided by 10 is 50, and that's approximately 19.64. Just take 982.24 divided by 50. And then recall that the present value of a unit annual level perpetuity due is 1 over d, and that you actually have to memorize this for the test. If you want to pass actuarial exams, you have to remember formulas. And the present value of a standard annual increasing perpetuity due is 1 over d squared. They actually give you 3 formulas like that in my study manual that you have to memorize. What's the value of a unit payment at time n? What's the value of a unit level perpetuity due but starting at time n? And what's a value of present value of standard annual increasing perpetuity due starting at time n? And you should memorize all 3. And the present value of a standard annual increasing perpetuity immediate is 1 over id. And you get that very simply by taking 1 over d squared and dividing it by 1 plus I. This is because the perpetuity due brings money earlier, so it's worth more. How much more? Well, it's moving money forward 1 year, so you earn, basically you have 1 more year to earn interest on it, and in 1 year money is multiplied by 1 plus I. So for I equal to 0.075, 7.5%, we have D equal to 0.075 divided by 1.075. That's approximately 6.9767.44%. and the perpetuity in question effectively consists of a level perpetuity due of 982.24 and an increasing perpetuity immediate of 19.64, and is therefore worth approximately 982.24 times 1 over d, which we just calculated, plus a 19.64 times 1 over id, and we just plug in those values, and that's approximately 17,833.16, which is answer A. So this problem was created by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.